All right, here we are. So now what we're going to do here is take a look at those problem sets from chapter 14. And so let's get them open. All right, so all right, here it is. Let's take a look. So what I'm going to do is enter the solutions onto this document. First, let me save it with a new name so I know which is which. So today is the 8th. Very good. So yeah, when we're done, I'll post this on Blackboard and you'll know which one it is because it says the word solutions on it. So here we go. So we're back to our old friend, triangular arbitrage. Now, hold on 1 second. I just realized I have to install my tablet before we do anything else. So let me just take care of that right now. Yeah, I don't have. Okay. Okay. Oh, I think it actually worked. What do you know? All right. So I can unplug that and replace it with my tablet. And then we can get started. This one, as you know, requires diagrams. So I can't do that any other way that I know of besides using this tablet. So we've got 3 exchange rates. And of course, what we're trying to do is determine if there's an inconsistency between them. And if so, how could we earn profits from that inconsistency? So we've got 3 pairs. Now, the strategy here is to look at the one cross exchange rate and compare it to the other 2, where it ideally would have been derived from. So we could start, for example, with, let's say, so our cross exchange rate is so many euros per pound. So you know what I'll do, I'll use the symbols. How about that? We've got a cross exchange rate. And you know it's a cross exchange rate because it does not mention the dollar. There's an implied mention of the dollar, but we're going to see if this is consistent. So at the moment, it takes 1.4381 euros to buy a pound. According to this is a quote given to us by a foreign exchange dealer. Now, whether it's correct or not is a different question. So we have these 2, dollars per euro and dollars per pound. Now, we're going to have to do one of 2 things. We're going to have to multiply them or divide them to come up with a quote in terms of euros per pound. All right, so what should we do? All right, well, you know how you can help yourself with this. You've got dollars per euro in this first exchange rate, and you have dollars per pound. So what you might want to do is try to divide and see if it works out, just the units. Now remember, this ratio is equivalent algebraically to pounds over dollars. Now this tells me that we've got it backwards because this is pounds per euro. So I don't want to take this one and divide by this one. It should be the other way around. All right, so let's try that one. If I take dollars per pound, actually, let me write it like I was doing it up here. Dollars per pound. Oops. Dollars per pound over dollars per euro. Algebraically, this is the equivalent of dollars per pound times the inverse of this one, pounds per dollar. These cancel out, and yes, indeed, we're left with euros per pound. So we're going to go back up here and take dollars per pound first. Actually, let me split the screen so I don't have to scroll back and forth so many times. And so the dollars per pound will be first. 1.7395 per pound. Okay, now I'm going to divide that by the dollars per euro exchange rate directly above it. 1.1893 dollars per euro. So now this is the equivalent of saying 173.95 dollars per pound times 1 euro per $1.1893. So the dollars cancel out. I'm left with the ratio of 1.7395 over 1.1893. So finally, after all of the dust settles, whatever that ratio is what I've got. So let's take out the calculators. 1.7395 is divided by 1.1893, and that's going to be 1.46. Oh, wait, hold on one second. I don't want this equal sign here. It's just 1.4626. Now, does that match up with the cross exchange rate that we were given? It does not. Okay, up here you see they gave us a quote of 143.81. So in other words, the quote that we were given is offering to pay too many euros for each pound that we give them. So we could bring pounds to them and they'll give us too many euros for each pound. That's the key as to what our strategy should be. Okay, so the dealer who gave us this bad quote, let's put this in here. The dealer is offering too many euros for each pound that we deliver. Therefore, in our strategy, we must ensure that at some point we trade pounds for euros. All right, so that's the key to the whole thing. You know, we can go around the circle and all, but we have to make sure that somewhere along the way we're selling our pounds to this dealer in exchange for euros. Now, according to this, we're starting with 10 million euros anyway. So that means that right off the bat, we don't want to sell our euros for pounds. It's the other way around. So that means we're going to have to go through the dollar and then work our way back to pounds and then back to euros. All right, now let me just show you how I did it. Now, by the way, of course, you can always choose to order the circles any way you like. This is one of the awkward parts. I probably should have mentioned or specified which way to go, just to make sure we're all doing the same thing. But as it turns out, no matter what order you put the circles in, as long as you go in the right direction, you're going to make money. Okay, so in the example, or at least my solutions, what I've got here is dollars in the bottom left-hand corner. Let me make that a little bigger. Up here, I've got euros. And here I've got pounds. Okay. All right. So I've got 10 million euros. That's my starting point. Now, what we can do is fill in the exchange rates. For example, dollars and euros are listed at 1:18.93. All right, so we don't have the hours yet. We can save that for last. Okay, so it's actually $1.18.93 per euro. For the euro and the pound, now the cross exchange rate that we were given, I'll move it over here to keep it out of the way. Oops, sorry, that's not dollars. It's 143.81. And then for the last one, dollars and pounds, the quote we were given is 173.95. Okay. $173.95. And while we're at it, let's just get this up here. All right, I think it'll look good there. It's because all that's missing is the arrows. Now, keep in mind that if you go the wrong way, you'll lose money and you can just go back and start all over again. So you're not really trading in real time, so it hardly matters. So as far as a test is concerned, if you start and you go the wrong way, you just reverse it. It's that simple. So you really can't mess it up, okay? Because one direction is correct and the other is not. The only thing that you want to pay attention to, though, is that if this implied cross exchange rate, which is what this is, let me just add that. Okay, it's implied by the other two exchange rates. And in other words, the one they actually give us, the quote, which is up here, this is the quoted cross exchange rate. Quoted meaning that some dealer out there is giving us this number, which isn't necessarily correct. That's why arbitrage is a possibility. Because if they give us the wrong number, we can make money, and it comes at their expense too. So that's why you don't really expect to see this, although it's not impossible. Conditions can change so quickly. I mean, in this day and age, hedge funds can take advantage of these temporary mispricings, even if they just last for fractions of a second, because computers are so fast. Computers can pick up on these small discrepancies and jump in and execute them. And so this is how a lot of these hedge funds make their money. Not necessarily in foreign exchange markets, but any markets can potentially have arbitrage opportunities. So it's tough. It's difficult to do this well. As a matter of fact, see, here's where the problem is. If the discrepancy is just a tiny fraction of a cent, the only way to make any money with this is to use borrowed money. And then suddenly it becomes very, very risky if something goes wrong. But anyway, in the meantime, let's see how we can make some money. So let's say this way. So always we have to pay attention to one important detail. When you convert one currency to the other, it's important to pay attention to whether we're supposed to multiply or divide. And again, you can just look at the units. Like here, for example, you don't want to multiply euros by euros per pound because then you don't get any cancellation. What you're going to need to do is divide, okay, to get the number of pounds. Let's come down here and do it. Split screen. So let me just show you quickly how that would work. We take 10 million euros. Divide by 1.4381 euros per pound. And again, algebraically, This is equivalent to multiplying this by the inverse. Because remember, the point of this is to eliminate the euros. We're converting all of this money into pounds. So by doing that, you're dividing 10 million divided by 1.4381 is about 6 million. $953. 619. 619, that's fine. You know, we can go to the cent, the pence in this case, but it's probably not necessary. You get, I mean, the discrepancy will be more than enough to compensate for that. So, I mean, for a hedge fund, no, you want every single digit, but here we don't really need that much accuracy. So then we go next to dollars. By the way, I mean, as soon as you start to go in a clockwise direction, you're going to continue to do that. You can't change somewhere along the way. It's either all clockwise or all counterclockwise. Now, here though, we're going to multiply these two together. Again, because we want to eliminate the pounds. Okay, hold on one second. So we'll have 173.95 per pound times 6,953,619. So you notice how the pounds cancel out very nicely. So let's see what happens when we multiply these together. Ooh, 12 million. 95,000. 820, let's say 821 dollars. Okay. 820 or 21, it hardly matters. You know, we're rounding a little here. So that means we suddenly find ourselves with 12,095,000. $821. So now the last step is to go back to euros. All right. So let's do it. Again, you can see you're not going to multiply them together because you can see you will not cancel out the dollars. We're going to divide. So let's do that. All right, let's just quickly run through that. And at the end, if you have more than 10 million euros, you made money. If not, that means you go back to the circle, the triangle, I should say, and go the opposite direction, and you're all set. So let's get a drum roll going. Let's see how many euros this is worth. Now, I mean, you can see visually, we're dividing by 1.1893. The numerator is 12 million. It's pretty clear that we made money, but let's just prove it. 12,095,821 is now divided by 1.1893. So we, oh yes, 10 million 170,538. Beautiful. So copy that up here. $170,538. That's it. We made money. That's it. We're done. Okay. So even if we made a euro, it's still a profit. But of course, then it might not be enough to cover the transactions costs. But basically, as long as there's a profit, you may as well go for it. So, and again, if you went the wrong way, what you would do is you simply go backwards. In this case, you would go, if you go on counterclockwise, at the end, you would discover your mistake and you reverse it. All right. And if you did put the circles in a different order, then for you, maybe counterclockwise was the way to go, but you would know right away, because when you come to the end, you would have a profit if you've done it correctly. The order really does not matter. I mean, here we're told to go to Europe first, but other than that, nobody said you have to put the dollars here and the pound here, for example. All right. In fact, I could have put the euros down here. It doesn't make any difference. All right, that was pretty easy. Well, no, it wasn't, but it was, at least now you see what you have to do. Okay, so let's go ahead. Now, the second one is a little trickier because we're dealing with the, not the major currency pairs. It's not that the Mexican peso isn't an important currency. It's just, it's not considered to be one of the really major currency pairs like the dollar and the pound and the euro and the Swiss franc. But so that being the case, I don't know if there's any symbols for us to use. The Canadian dollar usually is listed as C dollars. The Mexican peso is usually you just use CP used for that. So here we go. Now, as usual, this is our cross exchange rate because it does not have a dollar quote in it. So this is our cross exchange rate, the actual cross exchange rate that we were given. Okay. Now, we want to know before we do anything else if that is consistent with the other two. So we start out with Canadian and US. And then we have Mexican pesos. Now, if I put, well, see, we can't multiply them because the units won't cancel out. We're trying to get rid of the dollars. So let's, and when we're done, we want it to be pesos per Canadian dollar. So let's try this. So again, remember algebraically, I mean, you could cross these out. You know, you were taught probably in high school, you know, how to do something like that. But formally, what you're actually doing here is you're multiplying the one in the numerator times the inverse. And then you can see, yes, the dollars cancel out. So the ratio here, if you take 8.7535 divided by 1.419, you'll get approximately 6.8168, I guess we could call it 1688 per dollar. Now we come up here and we see that, oh, wait a minute. No, the actual quote they gave us was 6.439. So that means there's an arbitrage here somewhere. Okay, so right away we know that since the actual cross exchange rate is different from the implied cross exchange rate, there is an arbitrage opportunity. All right, that's all it takes. If they were the same, no matter what direction you go around the circle or the triangle rather, you would end up with the same amount of money. So that's how you would know that there was never an opportunity in the first place. So in my answers here, I put the dollars are down here. The Canadian dollars are here. And the pesos are over here. Does that matter? No, no. It's just that, that's how I chose to do the circles. Now, they tell us somewhere in here that it's a US trader starting with $1 million. All right, so we'll start here. So the exchange rate that they gave us was dollars per Canadian are 1.419. I'll just put it as C dollars. How about that? Canadian Mexican is, I'll put P for peso, 6.439. Per Canadian dollar. And then in the bottom, pesos per US dollar, it's peso 8.7535 per dollar. All right, so now what direction should we go? Well, why don't we go this way and see what happens? So the $1 million, now here you can see that we can't multiply them because you won't eliminate the units. So let's try dividing. And then that's the equivalent of multiplying by 1 Canadian dollar per 1.419 US. Now the US dollars cancel out. And the ratio of those two, let's see. No, wait a minute. Hold on. I think I did something wrong. Hold on a second. No, there's something not right here. What did I do? Oh, I think I copied it wrong. Yes, I did. Sorry. It was, that's why right here. No wonder it's not right. Well, that helps. All right. It helps you to write it down correctly. No, this was supposed to be 1.409 Canadian per US. Okay, so I copied it incorrectly. And that's why I messed it up down here. So we have to fix this now. So that means that instead of dividing, we are going to multiply. God. See how easy it is to mess this up? All right. So in other words, your $1 million is multiplied by 1.419. And this one is straightforward because you can see now we can just simply multiply. The dollars drop out. And so this converts into 1,419,000 Canadian dollars. All right. So we now have we now want to go to Mexico. And the question again is, should we multiply or divide? Well, this one also turned out rather well. Uh-oh, I just realized somebody's chatting. Okay, I see. Okay, good. Yeah, so you never know with the internet. So just do what you can. If you can't, if you miss too much stuff, you can watch the video. All right, so okay, yeah, I know the net is really not that reliable when you come right down to it. Well, what technology is when you come right down to it? None. Okay. No, that's right. So, all right, so let me just quickly, so we're going to multiply these together. Let me just split the screen. Yeah, I mean, you can kind of see just by looking at them that we're going to multiply again. These will drop out, and whatever that product is, it turns out to be approximately 9,136,141 pesos. So it seems like a large number, but there's a lot of pesos for each Canadian and US dollar. Although, I mean, in the real world right now, it's like 20 pesos per US dollar. It's not even close to what we're seeing here. Anyway, so we come back. I guess we'll end our journey next by bringing back those pesos into the United States. Man, we got lucky again. We're going to multiply one more time. Oh, sorry, no, we're not. We're going to divide. That's way too much. Oh, I forgot to copy it up here. That's what happened. All right, here we go. Yeah, sorry, we're going to divide. Okay, so let's prove it. We're going to take our pesos and divide by the exchange rate between the peso and the dollar. Which once again is the same as multiplying by this exchange rate, so many dollars per 8.75 pesos. All right, so we just divide. The pesos will cancel. All right. 9. Now you can see by looking at it, this is going to be more than $1 million, $1 million. But let's find out the exact amount. So it's 1,043,713, let's say. So it's more than $1 million. That's all we need to know. We made money. Okay, so that's that one. So that they're all the same. I mean, we don't really need to do any more. Like I said, it's always the same process. And so you can do as many as you want, but I mean, I think we get the idea. And again, if you went the wrong way, just reverse it at the end and you'll have the right answer. Excellent. Now we can go on to something else. which is, this is a straightforward one. The spot exchange rate between the dollar and the pound is 175. Fine. We also know that the US 6-month rate of interest is 3% and the UK 6-month rate is 5. So we can label these. E is 175. US rate is R, 3 months. UK, R star, 6 months. Now, it's 5%. So 6 months. Now remember, the formula is based on a 360-day year. So we're going to treat the number of days as 180 because we want to think of this as half a year. So the formula looks like this. And so when we plug in the numbers, we have, now what we could do is simplify it a little first. Half of 3% is 1%. Half of 5% is 2.5%. I think that makes it easier to do the calculations. So let's see what this turns into. 1.75 times 1.01 divided by 1.025. And so that's all you had to do for this question. The correct answer is the implied foreign exchange rate, which is the only one in which there will be no arbitrage opportunities, will be approximately 7244. Oh, wait a minute. I'm sorry. I messed it up. This is supposed to be 1.5. I just realized I goofed it up. That's what I get for not throwing in the calculator. Sorry. It's 1.5, 1 plus 0.5% in the numerator and 1 plus 2.5% in the denominator. So let me fix that. Oh yeah, it's too easy to make mistakes. Oh no, hold on. 1.75 times 1.015 divided by 1.025, about 1. Oh, here we go. That's better. 1.7329 per pound. Oops. And that's the answer. That's all we needed. Now, of course, we know that if the quoted forward exchange rate is different from that, there will be an arbitrage opportunity. We haven't been asked to do that just yet, but in the next question, we will. In fact, we're going to have to do this twice. All right, because we're going to be given 2 different exchange rates, forward exchange rates, neither of which is correct. All right. All right, so I'll leave it up there for a second so you can catch up, and then we'll go on to the next one. And this one, I strongly recommend that we do a diagram so you can visually see how this process is working. All right, so what's next? Assume that the spot exchange rate between the dollar and the pound is 170. Okay, that's the spot rate. The 90-day euro dollar rate is 2%. The 90-day euro sterling rate is 4%. And then we're going to make some assumptions about the actual or quoted forward exchange rates. So let's write some of this stuff down. E, the spot exchange rate is 170 per pound. N is 90 for 90 days. The euro dollar rate is 2%. Euro sterling is 4. So the first thing you should always do is calculate the implied forward exchange rate. Although it doesn't say that. I think it's a good idea. All right, so we've got 170, 1 plus 0.02. So this is 90 over 360, so it's basically a quarter of a year. All right, so in other words, what you essentially have here is 1.70. A quarter of 2% is a half a percent. So 1.005 is divided by a quarter of 1%, which is just 1%. So you end up with 1.6916, let's say. That's the implied forward exchange rate for 90 days. Anything else means there's an arbitrage opportunity. But in A and B, in part A, we're assuming that the actual quote is 171, which is clearly too high. And in part B, we're being told that the actual quote was 168, which is too low. So in the two cases, we're going to go in opposite directions. That much we know. All right. Now remember, in these diagrams, there's 4 parts to them. All right. So the tricky part, though, is unlike with the triangular arbitrage, where you're told where to start, here you have to figure that out too. You may start by borrowing dollars, and you may start by borrowing pounds. We don't know until we look at these numbers. So here, F is too high. All right, so what's going on with that? F is too high. Or I should say, I guess the quoted forward exchange rate is too high. In other words, each pound can be sold forward, it's called, for too many dollars. All right, in other words, each pound sold through a forward contract provides too many dollars. So what you're going to have to do somewhere along the way is make sure that you are in a position where you are to trade pounds for dollars through a forward contract. So let's do this. Now, does it say, yeah, start with $1 million. It just makes it's so much easier. And it's a nice round number. All right, so let's start with $1 million. In the US, that is. Now, there's 2 things going on here. Remember, arbitrage is meant to take place with borrowed money. Or failing that, let's say you're trading for a bank, you can use the bank's money, but nobody is using their own money. So the US rate, or sorry, the euro dollar market is here. If we borrow dollars, they're going to cost us 2%. But remember, this is only for a quarter of a year. So that 2% is the annual rate. And that means that in 90 days, I'm going to have to pay back all of this times 1 plus 2%. Actually, it should be, we could write it as 2% times 90 over 360, which is $1,005,000. This is how much we repay because this is borrowed money. So we take the borrowed $1 million, and the first step is convert them into pounds at the spot exchange rate, $1.70. And in a case like this, you're going to divide. So the number of pounds that you'll end up with is 1 million divided by 179. 170. So in your British pound or euro sterling account, you'll have 588,235 pounds. Let's say we're rounding it. And that is now invested for 90 days at the euro sterling rate. At 4%, but only for 90 days. So at the end of that time, we'll have this amount times 1 plus. Oh, I'm running out of space. Sorry, hold on. And that's going to be approximately, now keep in mind, what you're doing is you're basically multiplying this number by 1.01. So that leaves you with roughly 594, sorry, 594,000. 117. And that's what we're going to sell forward through this contract. As soon as we set up these arrangements, we enter into a forward contract with that dealer who offered us 171 per pound. And we're going to deliver 4,117 pounds in exchange for $1.71 each. So if you multiply those together, let's keep our fingers crossed. What we need to see is a number that's greater than $1,005,000, because this is how much we'll collect from our euro sterling deposit after converting the pounds into dollars. So we're going to get approximately, here we go, 1,015,941, let's say. So you collect this much. Sorry, you repay this much, you collect this much. So our profit is more than $10,000. Not bad for a few minutes work, especially if you let the computer do it for you. So the profit, hold on. I have to humor the tablet sometimes. So clearly there's a profit. We got 1,015,941 minus 1,005,000. So that's $10,941. Risk-free profit. It's basically free money. That's what arbitrage is. It's free money. But it only can happen if we have an inefficiency in the market. Like here, for example, if F was equal to the implied amount, you would see that you'll just end up with $1,005,000. So there'd be no point. Aha, all right. So in other words, the profit is coming from right here. These pounds are being converted, like I said, to too many dollars. 171 instead of 169 something. So the profit is coming from right there. The ability to trade your pounds for so many dollars is what is driving this. And of course, it's coming at the expense of the dealer who gave us this bad quote. Because they're delivering us dollars they're delivering too many dollars to us. When they get those dollars and they sell them in the market, they're going to end up with less money than they paid us. But that's their problem. All right, now we're going to reverse this because now all of a sudden we're changing our assumption to F is too low. All right, so we were going to go in the opposite direction, but we're not even just going to do that. We're actually going to start with pounds instead of dollars. All right, so hold on one second. Let me just bring this down here. For B, the quoted forward exchange rate is too low. Each pound purchased through a forward contract is too cheap. Okay. You must be in a position to trade dollars for pounds then. All right, so what we're going to do, and remember, the quote here is too low. It's 168. So what we're going to do is for the same setup, let's just say, and actually I forgot to mention this up here, start by borrowing $1 million. With this one, we're going to borrow $1 million worth of pounds, or 588,235. All right, and again, just to keep the numbers consistent, we're going to borrow 588,235. And then you work your way through the diagram. All right, so let's go to the bottom left-hand corner. And you start with the pounds. So now we're going to convert those into dollars at the spot exchange rate, which hasn't changed. It's still $1.70. And by design, that's going to give us back exactly $1 million. In other words, that's intentional. Just to make sure that, you know, we're dealing with the same amounts of money. All right, so we take our $1 million, we invest. This is, of course, the euro dollar market. This is 90 days only. So we saw earlier that this translates into $1,005,000. This is the receipt from our investment. That's our money. But remember, we have to pay back that pound loan. So we go to the foreign exchange market and forward market and say, all right, we have a contract where F is 168 per pound. Now, in the meantime, at some point, we're going to have to repay this pound loan. So this is 4% in the euro sterling market. And so remember before, we did actually multiply this number out. And it turned out to be 594,117. So we don't have to do that again. So this is how much we have to repay in our loan, because remember, we borrowed pounds. But we also are cashing in this investment where we're taking $1,005,000. And because we're converting them into pounds, we divide. And so this is the key to the whole thing. Because F is so low, let's see how much we'll have. 1,005,000 divided by 1.68 is 598. $214. That's how much we collect from our investment. Okay, so I'll move it down here. It got a little clumsy here, but the key detail here is that we still made money. All right, so the profit, even though it's denominated in pounds, it's still a profit. So that's going to be the difference between the two is $40.97, which doesn't sound like much. Remember, this is free money. Would you ever say no to 4,097 free pounds? Of course not. And of course, you notice too that the profit depends on how far off the quoted forward exchange rate is from the implied forward exchange rate. Here, it wasn't that far off. One penny and hold on. It was 1.16 cents, which isn't that much. So you can see how with these hedge funds, what if the discrepancy is only fractions of a cent? Then a trade like this, even with $1 million, they may only make a few dollars, but what they have to do then to make it worth their while is they borrow, let's say $100 million or $1 billion, whatever, and use that to make this strategy. Then they're making some real money. But if you use your own money, this may not be very profitable, but it's worth pursuing. All right. Now, by the way, if you go backwards, again, you'll end up with losing money. So that's how you'll know if you messed it up. And then, of course, you can just reverse directions. But this one, just remember, sometimes you start with the dollars, and sometimes you start with the pounds. That wasn't true with the triangular arbitrage. It would hardly matter where you started. All that mattered is to go in the right direction. Here, it does matter both what direction you're going and where you start. So if something doesn't turn out right, then you just reverse everything. Okay. So, all right. And as soon as you have a profit, you must have done it correctly. All right. What's going on down here? Okay, these are a lot more straightforward. These are the asset market model problems where the calculations are not nearly as intense. So you'll be happy to hear that. For example, first let's remind ourselves what this thing looks like. We have, and let's say just in general, we'll use RD for domestic, F for foreign, okay. And in this particular case, we're using dollars and pounds, so we can replace them. And if you need to know the equilibrium exchange rate, you don't have to memorize this. You should be able to do this algebraically. Watch what happens. When was the last time you did algebra? Well, it's been too long. That's my opinion. So let's do some algebra. It's like, running. You can't let it go too long. So the first step is to subtract the British pound rate from both sides. Oh my God, I just realized I left my laundry on. So I'm sorry, everyone. I have to go get my laundry out. It'll take me 2 minutes maximum.
Is that okay?
I'll be right back.
Want to knock me up there too?
Yeah.
Hold on 1 second.
Okay.
I'm probably gonna have to drop this class and suck the money up.
All right, I'm back. Sorry about that. All right, so let's carry on with this. So multiply both sides by E. And by the way, you don't have to do this. You can just try to just remember it or write it down. But I just wanted to remind you how this was done. Because, let's face it, you want to stay on top of those old math skills, don't you? They will serve you well. Now, at this point, you could solve for either the expected, you've already got an expression now for the expected exchange rate. You usually don't have to solve for that, though. It's usually E that we're interested in. Now, you might remember what I'm going to do here is factor this out. The E, we have two terms, the common factor of E. So therefore, when I'm done, I'm going to have, this is my final expression. Okay. That's how we solve for the equilibrium exchange rate. And it doesn't matter what currencies we're using either. Of course, you have to make a distinction between the domestic and the foreign currency because E isn't, after all, quoted as dollars per pound or the domestic currency per foreign. And that's important. So we'll try to be consistent here. So with the understanding that E means dollars per pound, this is how you would solve for E. All right, so let's see, what are they telling us? We've got the two rates, euro dollars are, all right, hold on 1 second. This thing, it's kind of annoying. We'll split the screen. There we go. All right, so we know that in 5A, euro dollar rate is 3. And of course, by the way, it's understood that these rates mean per year, unless it actually says something else. That's why we have to adjust them when we have less than a year. Now, with these asset market model cases, we're always assuming a year unless it says something different. It was completely different with the arbitrage because forward exchange rates typically don't go out a full year. So here, this is a little different because we're really kind of looking at a longer time frame. So these mean a year unless it says something different. Euro sterling is 4. And the expected exchange rate, and this comes from surveys in the foreign exchange markets, 150 per pound. And these, the expectations could be wrong. But at this point in time, if that's what we believe, then the equilibrium exchange rate will be, there we go, so you're taking the domestic rate minus the foreign rate plus 1, or this actually works out to be 0.99. And the ratio of 150 over 199 is approximately equal to 1.5152 per pound. Let's keep 4 digits after the decimal. All right, now they want us to graph this. And I think it's a good idea to always graph these relationships. You can visually see what's happening, especially when something changes. All right, so how does that work again? So remember how we defined this earlier. The exchange rate is here, dollars per pound. The return, which is simply a percentage, is here. We've got the dollar rate here, which we can see is 3%. The expected return of the foreign currency is here, and when they cross is, of course, the equilibrium exchange rate, which we just got through showing is $1.5152 per pound. Now, remember what equilibrium means. Equilibrium means, just quickly review that the supply of a currency equals the demand for the currency. All right, now we don't actually use supply and demand curves in this particular analysis, but going on behind the scenes are traders who are buying and selling currencies. The supplies come from those countries' central banks. The demand comes from investors or people who want to do business in those countries. And when there's a balance between the two, we find equilibrium. This is the exchange rate at which there is no tendency for change. In other words, there's no reason for anyone to switch their holdings. Everybody's basically happy right now. But then, of course, something has to come along and change. Naturally enough, these are the foreign exchange markets, after all. Something is happening all the time. And this time, that something is an increase in the sterling rate, euro sterling, to 5%. Okay. So in other words, the Bank of England is tightening monetary policy. And by the way, we're going to spend a lot of time with monetary policy fairly soon, because obviously interest rates rather have such a powerful impact on exchange rates. So we have to understand what these different central banks are actually doing, how they're doing it, and why they're doing it, and what impact it has in the markets. All right. So in the US, of course, we have the Federal Reserve System. That's our central bank. In England, they have the Bank of England. All right. Which, by the way, is the second oldest central bank in the world by 1 year to the Bank of Sweden. It's been around since 1694, compared to the Fed, which has only been around since 1913. So we'll spend a little more time on the history of the Fed when we get to that point, but it's quite interesting. The Bank of England has been around forever. And sometimes, if you've ever been to London, it's called the Old Lady of Threadneedle Street. I know why it's called Threadneedle. I mean, it's on Threadneedle Street, but I don't know why it's called the Old Lady. But that's just what they say over there. But anyway, each central bank can raise its rates or they can lower their rates, and whichever one happens will have an immediate impact on both currencies because it affects the relative attractiveness in terms of rates of return. So here the Bank of England tightens monetary policy. So what that means is that our pound, euro sterling rate, rises from the original 4 to 5. All right, so what we're going to do is recalculate. In fact, we can just take these numbers. We only have to really make one change. Oh, hold on. Oh, wait a minute. Yeah, see, I got to watch it. The problem with this tablet, as nice as it is, it sucks up an awful lot of memory. So, you know what I'm going to do here? Oh boy. I mean, yeah, it's already getting too full. Here we go. I'm going to move this to another document. I can see this is going to be a constant problem. Nah, you see, oh my God. See, it's already giving me a hard time. Hold on, this is a delicate operation I'm performing here. I've been there before, so I know what to expect. I have to be nice to it right now. I also have to buy a new computer. That isn't obvious. You know what? I'll tell you what. You probably don't need this algebra. It was nice to look at it, but I'm going to see what I can do about salvaging the rest of this. Because it's really being stubborn with me right now. You would never be asked to do this derivation anyway. I just wanted you to see how that was done. So that we got that. We have the graph. It's as far as we've gotten so far. And then we're being told that we're going to change something. Okay, so we're good. Now I'll just copy these. All right, so hold on one second. Okay, now this one. I'll keep these and I'll get rid of the rest of this. All right. Okay, I think I've saved the day. Because of course, when we're done, I'm going to post these on Blackboard. Oh yeah, okay, everything's good. All right, so it's just going to be chapter 14, problems with solutions, today's date. And then the second part will just be the same thing, only part 2. Okay. So now we can carry on without any interruptions. So what's going to happen here is that we change the euro sterling rate to, I was just trying to copy this. That's what it was. All right, beautiful. So we change this to 5. Yeah, we hardly have to do anything. So this is now 0.98. And so you can see that because we're dividing by a smaller number, we end up with a larger ratio, 1.5306. Now, here's what I want to, we don't really have to redraw the whole graph again. It asks for a new graph or another graph, but what you can really do is just take the same one and show the change. So we'll do exactly that right now. We'll call this 1. And then that will be 1 because that's the original value. And since the new interest rate in England is higher than the old one, the curve is basically shifting up or to the right, depending on how you look at it. And so here we're at 2 with our new higher equilibrium exchange rate of 1.5306 per pound. And that's it. That's the whole problem. We started out with an equilibrium exchange rate of 1.5152. After English interest rates went up, the dollar got weaker because people are more likely to buy pounds now or invest in pounds. So therefore, the curve shifts up for the foreign rate of interest or rate of return, and we end up with our new result. All right. Now, all 3 of these questions are exactly the same, by the way. It's just they all have different numbers. So for 6, let's take a look. Oh, this time, just to make it fun, we've got Euro Swiss franc. Yes, there is a Euro Swiss franc rate. So our dollar is 3. We'll call it just RSF. It's 2. And the expectation is 95 per Swiss franc. Now, I think the first night I showed you how the actual official abbreviation is CHF, but we'll stick with SF for now. All right, so we can go to our formula and figure out the equilibrium exchange rate. And as long as it's still dollars per unit of foreign currency, we can continue to use the same formula. So you have 90.95 over 1 plus 0.03 minus 0.02 . And that's going to be 0.9406, let's say. Per Swiss franc, that is. Okay, now, we'll draw it. Every time I save it, I've got my fingers crossed that it doesn't blow up. Just because these drawings are nice, but like I said, they take up an awful lot of memory. So the equilibrium is 0.9406. And so what changes in part C, that's the graph is part B, by the way. Part C, the euro dollar rate falls to 2%. Okay. So in the US, rates are being cut. All right, I'll do it again. It's like, it looks ugly. I'll do this. So the US rate was previously 3, now it's only 2. So you can see what's going to happen. We're going to have 1 in the denominator, which is just 95 cents per Swiss franc. All right. So I'll tell you what, this time I'm just going to do it on the same graph, just because I'm worried about running out of space. Memory, that is, not space, memory. So I'll shift it up here. Oh, no, sorry, my mistake. Hold on. I just realized I shifted the wrong curve. You're supposed to shift this one to the left because it's the US rate that changed. And that looks good because it's 0.95 here. So this is actually both B and D. Let me change that. All right, so this time it was the US rate that changed. And of course, by having a lower US rate, that makes the dollar relatively less attractive than the Swiss franc. People will sell their dollars to hold more Swiss francs. And as a result, the dollar gets weaker. All right, now, there's one more. And let's see, wow, hopefully it'll let me do this. Yeah. This time, again, just for the fun of it, I've chosen the Swedish krona. How do you like that? We haven't seen that one before. Now, the Swedish krona is often abbreviated SEK, and the krona is the name for crown in Swedish. In fact, it turns out that Denmark, Norway, Sweden, and Iceland, all of them have their currency is called the krona for crown, and all 4 of them. Because, they're all Scandinavian countries. I'm sure their languages all evolved from the same sources. So anyway, what's going on here? We have the dollar rate is 3. In fact, they're all ultimately, Vikings lived in all those countries. Their languages may come from the Viking language. Wouldn't surprise me. Euro krona is 1. And the expected exchange rate is 15 cents per krona. So the equilibrium is easy to calculate. So it's 0.15 over 1.02, which is approximately equal to 0.14706, or about 14.7 cents per krona. Beautiful. So we'll draw it in. And the graph is the same, except that it's a different currency. About like I said, 0.14706. And then we have a change in part C. The exchange, what happened differently? Oh, I think it's the expectations this time. The expectation rises to 18 cents per Swedish krona. Which means that the dollar is, people are more pessimistic about the dollar relative to the krona.
Do you feel that worked?
There's something wrong, he says, outside. But he's gonna have someone here tomorrow between 6 and 7. He'll call me before he shows up. They'll check outside and then they'll swap out the modem.
Okay. 6 and 7 in the morning?
At night.
All right, so therefore, the numerator is higher, so obviously E will go up as well. The interest rates haven't changed, 3% and 1%. So you end up with 18 over 1.02. And that's going to be roughly 0.17 647. And it's higher, as we would have expected, because the numerator went up. So like I said from before, I would like to use the same curve just because I'm afraid of running out of memory. Hold on one second. So this is the value that's going up. So we'll shift the curve up. That'll be 1. This will be 2. And so this is where we are now. 1.7647. And so the dollars we predicted got weaker just because people are more pessimistic about it. And that's it. Okay. So that was, now 14, of course, is by far, it's a very complicated chapter because of all the arbitrages. But after that, it starts to become less involved with, I don't think there's any more arbitrages. After this, we're looking at the theory that we're developing, the asset market model, and how different factors affect the strength of the dollar. And then we'll start to study in more detail monetary policy. And then we'll start to look at how exchange rates are determined in the long run. Because remember, this is a short-term model we're looking at now when prices are assumed to be fixed. Once that changes, then that will complicate our results. But for now, this is what we have to do. So the next step is, of course, to go back to 15, but before we do that, we obviously have to have our break. And so let's do that right now. And I'll see you all in a little bit. Okay. All right. So yes, I'm sure everybody can use something to eat or drink. So I'll see you all in a bit. All right. So now last time it started 15, but I don't remember how far we got. Let's just double check this. Oh, right. I think we just barely started to talk about monetary policy. Does anyone remember how far we got? Pretty much right about here, right? Well, all right, it doesn't matter. We'll start at the beginning again. So chapter 15 is where we're going to start looking at monetary policy more seriously. And we're going to see how interest rates are determined by the central bank of each country. And as you know, the central bank has many duties, but one of them is to carry out monetary policy. In fact, that's really their primary responsibility. In the Fed's case, for example, their absolute top priority is to keep inflation in check, which usually means at 2% or less. It's not always possible to do that, but that's their long-term goal. Now, other countries have different levels of inflation that they target as well. Typically, it's right around that neighborhood, 2 to 3% per year, but they're all a little different. Okay, so we start out by just noting that monetary policy, well, first of all, it refers to their ability to control the money supply, which in turn influences interest rates. The central banks don't really have quite the control that people may think that they do. They can influence variables in the economy, but they don't, for the most part, control any of them. Even the money supply itself, they're not completely in control of it because it depends on factors such as how much money do people want to borrow, how much money do banks want to lend, do people want to hold currency, and that type of thing. So their control of it is not complete. I mean, it's somewhat indirect, but their job is really to nudge interest rates in the direction that they think is most appropriate. So their overall goal is to keep inflation in check, but yet at the same time, they'll not let unemployment get too high either. So in other words, the whole point is they want to have a sustainable growth rate, which typically means 3% real GDP growth, along with ideally low and stable inflation. If they can achieve both of those, that's fantastic. A growth rate of 3% per year should ensure that unemployment doesn't rise, or at least not very much. So you're sort of always balancing these two contradictory objectives. Inflation should be low, but so should unemployment. When the economy isn't doing particularly well, usually there's a trade-off between those two. It's usually very difficult to have both. Sometimes the central bank has to make a choice between less inflation and less unemployment. So their job is not easy. Now, there's two basic types of monetary policy that they can carry out. Expansionary refers to the money supply. If the Fed decides that it's time to carry out expansionary monetary policy, that means that they're trying to stimulate the economy. As we'll see in a couple of minutes, because expansionary monetary policy actually lowers the rate of interest. If the economy is overheating and inflation is getting out of control, they will instead conduct what's called contractionary monetary policy, where the word contractionary refers to the fact that they're reducing the size of the money supply. The point of that is to raise rates to slow down the economy. Now, you might not think that's such a good idea, but if inflation is starting to get out of control, that's really the only way that they can stop it, by slowing down economic activity. And the best way to do that is to raise interest rates. All right. So in other words, I mean, because so many things depend on interest rates. For a business, for example, they need to borrow money to run their operations, or they may need to simply use it to expand into other markets or develop new products. Higher interest rates increase the cost of doing business. And so therefore, higher interest rates will slow down business expansion, which will in turn slow down the economy. From the consumer's perspective, of course, if interest rates determine the cost of credit, it also determines, for example, if you wanted to buy a house, the mortgage rate depends on the level of interest rates in the economy, or if you want to buy a new car. Obviously, the higher interest rates are in the economy, the higher you'll have to pay for your car loan. So higher interest rates tend to discourage spending by consumers on expensive items like cars and houses and furniture and appliances. In other words, the things that tend to be financed with credit. So the Fed will raise rates, slow the economy if they're concerned about inflation. On the other hand, if they're concerned that the economy is too weak, they'll do the opposite. They lower rates to strengthen the economy because then businesses will spend more and so will consumers. So why don't we take a look at the cause and effect here. We start with expansionary monetary policy. The Fed increases the money supply through whatever method is available. The effect of that is that interest rates decline. Why is that? Because more money is available for the banks to lend out to their customers. And in order to entice their customers to borrow more money, one way to do that is to lower the rates of interest. Okay, so in other words, if the customers aren't offered, or they've already borrowed as much as they want to, lower rates will encourage them to borrow even more. And of course, buy goods and services. So you can see lower interest rates stimulate investment activity by businesses and consumer spending, or at least on expensive items. And therefore the economy should grow. And in the process, unemployment drops. Now, unfortunately, if we keep this up in the long run, inflation will start to rise. So there's a limit to how far we can push this. All right, so that's always the holdup. Otherwise, we would just expand the money supply forever. But instead, we have to watch it because eventually that will trigger more inflation. So that's how it works. Okay, so it starts with the money supply, which the Fed is influencing. The interest rate decline depends on other factors. The Fed doesn't actually change the rates directly. What they're hoping to do is influence them. In this case, influence them in a downward direction. But ultimately, they can't force the banks to lend money, and they can't force consumers to borrow. So that part of it is up to the private sector. But normally, that's exactly how it works. Okay, it's not really that much of a problem. But sometimes during a financial crisis, though, like during the credit crisis of 2008, for example, the Fed tried to make a lot of liquidity available to the banks. The banks were afraid to lend it out because of what was going on. So it was very difficult to get the economy moving again after the credit crisis. Okay. And again, it's because the Fed they can make funds available to the banks to lend out, but they can't make the banks lend and they can't make people borrow. So that took a while. That little recession we had back then took a long time to resolve itself. Now, contractionary, everything just works in reverse, of course, as the name suggests. The Fed reduces the money supply, interest rates start creeping up again. That makes it more expensive for consumers and businesses to borrow, so they borrow less. Spending goes down, and therefore GNP falls as well, or at least it doesn't grow as quickly. So unfortunately, that raises the unemployment rate. But it also reduces the rate of inflation. So sometimes their policies will have some, and normally their policies, whichever type they undertake, will have some beneficial effects and some harmful effects. So it can't really be helped. The question is, you have to prioritize. What seems to be the problem that we have the biggest issue with today? Now, again, remember, we're still assuming fixed prices. So in the short run, when prices are fixed, interest rates ultimately are determined by the supply and demand for money. Specifically, in some books, they refer to it as loanable funds. In other words, how much are businesses and consumers willing to borrow, and what funds are available from savers. The supply of loanable funds ultimately comes from savers. So that's something we have to take into account when the Fed at least tries to conduct monetary policy. So the supply of money, we're going to keep this simple. We're going to assume that it is a fixed constant. The Fed chooses the money supply, and that's the end of it. But in reality, it doesn't always work that way. But what actually does happen is the central bank, or the Fed in our case, does control something called the monetary base. And the money supply is closely related to the monetary base. And in fact, let's jump ahead quickly and see what the monetary base is all about. So we're going to look at the Federal Reserve's balance sheet. Now, if you've had an accounting class, you know what this is all about. A balance sheet shows a corporation's assets and liabilities, as well as their equity. In other words, the assets represent what the corporation owns, buildings and, equipment and all this and that. And then the liabilities are what they owe. And if there's anything left over, hopefully there's more assets than liabilities. And if there are, then what's left over is called equity. All corporations have a balance sheet. Individuals could be thought of as having a balance sheet. You have assets and you have liabilities, and you probably have equity. It could take the form of ownership of a house. It could be ownership of stock, but you can't have any equity unless you have more assets than liabilities. The Fed is a different case altogether. The Fed is a nonprofit organization, and it does not have any equity. All it has is assets and liabilities, which officially are equal to each other. Theoretically, at least, the equity in the Fed is zero. So what kind of assets and liabilities do they have? I mean, they're not running a business here. What exactly do they own, and what do they owe? Well, on the asset side, the Fed often will make loans to banks that are in trouble, and those are assets because they expect to be paid back. They also own a very large portfolio of treasury securities. The reason why they do that is because they're trying to help the government reduce the amount of debt that they have. So if they have any surpluses, they'll use them to buy treasury securities and help keep interest rates low. They also have foreign securities. Mostly these are bonds issued by foreign central banks, like the Bank of England, for example. Those can be used, as we'll see in a later chapter, to intervene in foreign exchange markets. Okay, so the Fed at any given time will own bonds issued by the governments of the UK and France and Germany and England and all the rest. Those are denominated in foreign currencies, so we can use those to intervene in foreign exchange markets. So you can see that the monetary base officially equals the sum of those assets. But if you look on the right, we have liabilities, and officially the monetary base is also equal to the sum of the liabilities. Now, it's usually easier to think of the monetary base in terms of the liabilities. Currency in circulation, believe it or not, is considered to be a liability of the Fed. Now, this made a lot more sense in the past when the notes that we had in our pockets could be redeemed for gold or silver. Okay, in other words, up until the early 30s, you could take dollar bills that were listed, and the dollar bill, it would say the words gold certificate, and you'd be allowed to trade them for gold anytime you chose. Up until 1964, there were also silver certificates, which meant that you could trade them for silver anytime you chose. And of course, that meant that the Fed had to have enough gold and silver on hand to cover the notes that it issued. So in that case, the notes were actually a true liability of the Fed in the sense that people could require them to pay back all this gold and silver that they were promised. Not anymore. They don't have to give you anything. There's nothing backing up our money. In fact, I'll tell you what, let's just quickly do a little detour here and take a look at a picture of a US gold certificate. And you'll see, like this one, it's a $1,000 bill. At the time, it had Alexander Hamilton on it. And you can see it says in here, in gold coin, payable to the bearer on demand. In other words, you can walk into a bank and say, listen, I want you to give me $1,000 worth of gold for this note. The money was literally backed by gold. This is 1907. So every time the Fed issues notes like this, potentially they could be on the hook for providing $1,000 in gold to the owner of this note. Then we had silver, $5.99. Oh my God. So this clown finally realized that it's a fake. Yeah, I think so. For $5.99, no, that's not real. And then we have silver certificates. Actually, I think I see one right here. That's a $2 bill. two silver dollars. It actually says the word silver certificate from 1899, but these were issued up until 1964. And again, you could take it to any bank and say, listen, give me silver. And then the bank would have to give it to you. So now, what does it say on there? Nothing about gold or silver. It actually says the words, well, let's make it a little bigger, Federal Reserve Note, which simply means it was issued by the Federal Reserve System. That's it. There's nothing in there that says anything about giving you gold or silver. You're holding this thing in your pocket because you have confidence that you'll be able to spend it somewhere. Okay, that's it. That's what's backing it up, confidence, nothing else. There's no gold, no silver. Anyway, so that being the case, this is still technically a liability of the Fed, but it's not exactly the same, okay? But we still treat this as a liability of the Fed. And then bank reserves. Now, for this, we need to do a little detour. What happens with the Fed is this. In order to preserve the safety of the banking system, the Fed basically is saying you may not lend out every dollar that you have. Okay, so in order to preserve the safety of the banking system, the Fed requires banks to hold a small percentage of their deposits in a special account with the Fed. This account, the money, the funds held in this account are known as reserves. So in other words, you know that the banks make their money by lending out their deposits to other customers. So if you put money in the bank, the money you put in there potentially has been lent out to somebody else who needed a car loan or a mortgage or whatever the case may be. So if we all got together and went back to the bank and asked for money at the same time, it wouldn't be there. In fact, at any given time, probably less than 10% of the deposits are actually in the bank. So the Fed knows that one of the things that contributed greatly to the Depression was what are called bank runs, where people panicked and they asked for their money back from banks, which clearly didn't have them because they lent them out to customers. So even safe banks suddenly went out of business because people got it in their heads that they wanted their money back right away, and it just wasn't there. Now, by the way, in this day and age, we have federal deposit insurance, which means that our deposits are guaranteed up to $250,000. So there's really no need for bank runs anymore, but still, in order to maintain integrity of the banking system, the banks have to hold some of those deposits in the form of account, reserves with the Fed. Now, the amount was, it depends. For small banks, it could be as little as 3% or even 0 in some cases. For the larger banks, it could go as high as 10%. But once the COVID broke out, the Fed announced that for the time being, the banks could feel free to lend out all of their funds if they needed to. So in other words, at the moment, they're not required to hold any reserves, although many of them do, but it's no longer mandatory. Now, of course, when the COVID is over, that will change. But right now, at this moment, the banks are not actually required to do this anymore. But the point of this is that those reserves belong to the banks, not the Fed. So that's why they're listed here on the right-hand side under liabilities. This is money that actually belongs to the banking system that the Fed is holding on to. So both of these are known as liabilities. And most of the time when you see formulas involving the monetary base, we use this definition rather than this one. And plus, it's just easier to find out how much these numbers are. These are more, the Fed is a little more secretive about these, but these we can find out how much they're worth. Okay, so the monetary base can be thought of in both ways, but we'll think of this as our definition: currency plus total reserves. The important detail with the the monetary base is that the Fed is directly in charge of the monetary base. They can change the quantity of currency in circulation. They can change the total reserves all by themselves. They don't, I mean, if they change them, then they go up. End of story. Their influence on the money supply is indirect, but the Fed has direct and complete control of this monetary base. So that is important because that, as we know, as if they change the monetary base, the money supply will be affected, but not necessarily by the same amount. So in other words, if the Fed adds $1 million to the monetary base, it doesn't necessarily translate into $1 million increase in the money supply. It could go up by more, but it could also go up by less. So that does make their job a little bit more challenging. And by the way, the existence of all the technology that we have to make it easier to, for example, shift your funds between your checking and savings account online or pay bills online and all this wonderful stuff we can do now, that makes it harder for the Fed to keep track of the money supply. You know, it used to be fairly easy for them. Now the technology is making it a lot more challenging. That's about the only drawback to all this wonderful technology that we have. It's so wonderful that we can do all these things quickly and easily, like pay bills online and, you know, receive funds very quickly and maybe invest in, you know, you can have like an investment account with your checking account, you know, all kinds of wonderful things are possible now. Or this is one of my favorites. You can deposit a check in your checking account by simply taking a picture of it with your iPhone. Oh boy, that's a helpful one. I like that one a lot. Or, you know, we don't think about these anymore because we take it for granted, but just the mere fact that you could deposit a check in an ATM overnight, that was never possible until relatively recently. You had to go to the bank when it was open and that was it. Now just pop it in the ATM and you're all set, or even better, take a picture of it. But the drawback to that is that the Fed's job is even that much harder. Well, that's, you know, that's their problem. I mean, I like the technology, but yes, it does make things trickier for them. All right, now you may have heard this in the news. The federal funds rate, which is often known as the Fed funds rate. What is that all about? Well, the banks, under normal conditions, do not earn a lot of interest on their reserves with the Fed. Okay, in other words, they don't want their funds at the Fed. They'd rather lend them out to their customers. So here's what they do. Let's say that a bank is required to hold $1 million in its reserve account. They're going to lend out every dime they can until they have exactly $1 million left in that account. They don't want to hold any more than is absolutely necessary. But sometimes they can run a little short. What do? They can either just get in trouble with the Fed, or they can borrow what they need from other banks that have surplus reserves. So there's a huge market where the banks borrow and lend reserves among themselves, and that market is called the federal funds market. Okay. So actually, let me sneak this in here for a second. Maybe we could use a new slide. The banks may borrow and lend reserves among themselves in the federal funds market. The rate that they charge for these loans is known as the federal funds rate, or sometimes the Fed funds rate. So the Fed doesn't choose this rate because it is a free market rate. I mean, they don't tell the banks what to do for the most part. I mean, they regulate the banks, but they can't basically tell them what they can and cannot do with their own loans. So the Fed doesn't set this rate. What they do is something more indirect. Instead, they set a target for this rate. So when you hear in the news that the Fed is raising rates, what they're actually doing is they're raising the target for the Federal Reserve rate. And what happens is if the actual rate deviates from this target, the Fed can jump in and they can manipulate the money supply. They can increase it or decrease it until the federal funds rate matches their target. Now, we're going to see more of this when we dive more deeply into monetary policy. But we don't want to get too carried away tonight because it's getting late. But just to give you the big picture, the Fed can engage in what are called open market operations, where they can either increase or decrease the money supply, or I'm sorry, the monetary base, by engaging in one of these two operations, which involve either the purchase of treasuries from the banking system or the sale of treasuries to the banking system. Okay. So in other words, they own a huge portfolio of treasury securities, and sometimes they'll buy more of them from the banks, and sometimes they'll sell some of them to the banks, depending on what they're trying to accomplish. Often the motivation is to keep the federal funds rate as close as possible to its target. Now, that Fed funds rate, as it changes, it affects all the other interest rates in the economy. So in other words, if the Fed funds rate starts creeping up, typically so will all the other rates in the economy. In other words, the rates charged for credit cards, bank loans, car loans, mortgages, you name it. Okay. So by just nudging up or down the Fed funds rate, the Fed is in effect setting rates or influencing rates in the rest of the economy. But every single day, they may have to get involved in one of these operations as the Fed funds rate may drift away from the target. And so they need to keep it there in order to achieve their objectives. Okay. So, all right, anyway, so we don't want to get too carried away with this, like I said, and we do want to discuss the actual structure of the Fed at some point, because it's a very interesting story. But right now, I think we had quite enough. I think you'll agree. So we'll let it go. We'll stop right about here. And next week, we'll pick it up and we'll spend the whole class talking about the Fed and monetary policy. And then if there's time, we can sneak into chapter 16, where we start to look at long-term determinants of exchange rates. Okay. All right. So I think we're good for now. So I will be posting our solutions on Blackboard so you can go through them. Oh, I missed that one. Sorry. Yes. Thank you. Have a nice week. All right. So I'll see you all next Tuesday as usual.
Thank you, Professor.
All right. Good night.
Professor.
All right. Okay. Bye.
Thank you, Professor.
See you later.